This question is fairly straightforward, but to do it, we've got to be aware of quite a few facts concerning the manipulation of surds and powers, which I have listed here. So we take the original expression and we factor the power of 3/2 into 1/2 times 3. And now we apply the fact that a to the power of n times m equals a to the power of n raised to the power of m, which gives us 27/100 to the power of 1/2, all raised to the power of 3. Now we use the fact that u to the power of 1/2 equals the square root of u to produce the square root of 27/100 cubed. And now we factor 27 into 3 squared times 3. We apply the fact that the square root of a over b equals the square root of a over the square root of b to produce the square root of 3 squared times 3 over the square root of 100 all cubed. And now we use the fact that the square root of ab equals the square root of a times the square root of b, and we find that the numerator decomposes into the square root of 3 squared times the square root of 3, and the denominator becomes 10, which simplifies to 3√3 over 10 all cubed. Now we know that a over b to the power n equals a to the n over b to the n, and so our expression becomes 3√3 all cubed over 10 cubed. But we also know that a times b to the power n equals a to the n times b to the n, which when applied here gives us 3 cubed times √3 cubed over 1000, which is the 10 cubed. And 3 cubed is 27. We split up √3 cubed into √3 squared times √3, to produce 27 times 3√3 over 1000, since √3 squared is 3, which finally simplifies to 81√3 over 1000. Part B. By considering the sequence of square numbers, show that 5 is less than 3√3 and 3√3 is less than 6. And we first note that from part A, 3√3 equals √27. Now, here is the sequence of square numbers up to 64. And here is the sequence of integers which we square to produce that sequence of square numbers. And we note that 27 lies between 25 and 26. And 27 is of course significant because √27 equals 3√3. And now, on taking square roots of both sides of the inequality that we've just written, we see that √27 lies between 5 and 6. And that's because if a is less than b, then √a is less than √b. And so we have that 3√3 lies between 5 and 6 as required, since √27 equals 3√3. Now, in this problem, I've used this fact that if a is less than b, then √a is less than √b. But you may be wondering, why is it true? Well, in fact, it's quite easy to prove, and I will show a straightforward proof here. First, however, note that both a and b have to be greater than or equal to 0 because we can't take the square root of negative numbers. And we should also note this important fact that the square root of x is always greater than or equal to 0. And so we have that a is less than b, which means on subtracting a from both sides, that 0 is less than b minus a. Now at this point we want to introduce some square-rooted quantities, and we do that by decomposing b minus a using the difference of two squares identity, which produces 0 is less than √b minus √a times √b plus √a. And now we note that √b plus √a is greater than 0, because of course root x is greater than or equal to 0 for all values of x. And that means that we can divide away root b plus root a from the right-hand side of this inequality to leave 0 is less than root b minus root a, which gives, on adding root a to both sides, root a is less than root b, as required. And so we have shown that if a is less than b, then root a is less than root b. Part C. Let 3 root 3 equal 5 plus x, where x lies between 0 and 1. 1. Show that 3 root 3 equals 5 plus 2 over f of x, where f of x is a linear function of x. 2. Hence show that root 3 lies between 19 over 11 and 26 over 15. Now, before we start, we should note that we know that 3 root 3 equals root 27. Part 1. F of x is a linear function means that f of x equals ax plus b, where a and b are real numbers. And we note that we have two different ways of writing 3 root 3. We can write 3 root 3 equals 5 plus x, or 3 root 3 equals 5 plus 2 over f of x. And by considering the three quantities shaded green, we see that we can write x equals 2 over ax plus b, where ax plus b is a linear function. Our job here is to determine exactly which values a and b have. And we must do that by considering the quantity in the blue box, 3 root 3 equals 5 plus x. So we have 3 root 3, which equals root 27, equals 5 plus x. And we can get rid of the unpleasant square roots by squaring both sides to give 27 equals 5 plus x all squared, which squares out to be 25 plus 10x plus x squared, which becomes 2 equals 10x plus x squared on subtracting 25 from both sides. And we can factor that expression into x times 10 plus x. So we have that 2 equals x times 10 plus x. And we note that 10 plus x is a linear expression. So on dividing by 10 plus x, we have that 2 over 10 plus x equals x, which is an expression of the required form, and which we can substitute back into our original expression. And when we do that, we find that 3 root 3 equals 5 plus 2 over 10 plus x, which is an expression in the required form. For part 2, we have to show that the inequalities here follow from the fact that 3 root 3 equals 5 plus 2 over 10 plus x, and from the fact that x lies between 0 and 1. And to do that, we take the two inequalities implied by this expression and use them to construct this expression in two different ways. So we start with 0 is less than x, x is less than 1, and we add 10 to both sides to construct the inequalities 10 is less than 10 plus x, 10 plus x is less than 11. Which we can separate into the two distinct inequalities 10 is less than 10 plus x and 10 plus x is less than 11. And we start with the inequality 10 is less than 10 plus x. So 10 is less than 10 plus x tells us that 1 over 10 plus x is less than 1 over 10 by dividing through both sides by 10 and 10 plus x, and on multiplying through by 2, we find that 2 over 10 plus x is less than 1 over 5, and on adding 5 to both sides, we find that 5 plus 2 over 10 plus x is less than 5 and 1/5, which equals 26 over 5. And now we follow a similar process with the inequality 10 plus x is less than 11. And so if 10 plus x is less than 11, then 1 over 11 is less than 1 over 10 plus x. And on multiplying through by 2, we find that 2 over 11 is less than 2 over 10 plus x. We add 5 to both sides to find that 5 and 2/11 is less than 5 plus 2 over 10 plus x, which is the same as saying that 57 over 11 is less than 5 plus 2 over 10 plus x. And so on combining the two inequalities that we constructed, we see that 5 plus 2 over 10 plus x lies between 57 over 11 and 26 over 5, which means that 3 root 3 lies between 57 over 11 and 26 over 5. And on dividing both inequalities through by 3, we find that 19 over 11 is less than root 3 is less than 26 over 15, as required.